So good afternoon to one and all. Your course name System Design and Control. In that your module 2, that is the time response and analysis. So what is the time response? You have two responses exist, that is in a time response. First one is a transient response and second one is a steady state response. So in case of your transient response, a transient response is the response of the system and the system changes from one state to another. Whereas the response of the system when it approaches to infinity is called as a steady state response. So next we look on to standard test input signals. So we have so many standard input signals, so we can discuss it one by one. First one is a step signal, and at the same time we have a unit step signal, ramp signal, and followed by a unit ramp signal, and a parabolic signal. Also we have a unit parabolic signal, and the impulse signal, and a sinusoidal signal. So these are all the standard signals that can be used in your control system. So let's discuss it in one by one in detail. The first one is we look on to a step signal. So step signal is a signal whose value changes from 0 to a. That is, when we look onto a graph at time t is equal to 0, we have an amplitude of a, and it remains constant at a for if t gets elapsed. So the mathematical representation of the step signal r of t that is equal to 1 when t is greater than or is equal to 0. So next we look on to a ramp signal. So ramp signal is a signal whose values increases linearly with the time from an initial value of 0 at t is equal to 0. So the ramp signal resembles a constant velocity input to the system. A special case of ramp unit signal is where a is unity. So again the same, that is there is a linear relationship between your time and your input, that is r of t that is equal to a into t, and again that is t is greater than or is equal to equal to 0, and for another if it is like that 0, it means that your amplitude is also 0. Next we look on to your parabolic signal. So in the parabolic signal, the instant value varies as a square from time from an initial value of 0 at t is equal to 0. The sketch of the signal with respect to time resembles a parabola. The parabolic signal resembles a constant acceleration input to the system. A special case of the parabolic signal is a unit parabolic signal in which a is a unity. So the mathematical representation of the parabolic signal is r of t that is equal to a t square by t, and if it is a unity, in the sense a is equal to 1. Therefore it varies with respect to square. So next, impulse signal. Impulse signal is a signal of very large magnitude which is available for very short durations, that is impulse signal. And here the mathematical notation, that is rho of t that is equal to infinity where t is equal to 0, and here integration, that is limits varies from minus infinity rho of t of dt that is equal to a, and for rest of the value it becomes 0. So next, the standard test signals. So the standard test signals here it is a state and time domain equations of a signal r of t that is a, and once if we take a Laplace transform here r of s that is equal to a by of s. For a unit step input signal and for a time domain it is 1, a is equal to 1. Therefore again if we take a Laplace transform for a unit step input, that is r of s that is equal to 1 by of s. Similarly for a ramp signal, that is a of t, a into t, and once if we take a Laplace transform, that is r of s that is equal to a divided by a square. For unit ramp, a is nothing but 1, therefore we have a t alone. Again if we take Laplace transform of t, that is equal to, that is r of s that is equal to 1 divided by a square. For a parabolic signal, you have a t square by t, that is equal, once if we take Laplace transform of a t square by t, it becomes a divided by as cube, because a is constant. For unit parabolic, t square by 2, and once if we take a Laplace transform, that is equal to 1 by of a square, and for impulse signal dou of t, that is equal to, once if we take a Laplace transform for dou of t, it again is equal to 1. Next we look on to your response of first order system for a unit step input. So why we have called first order system, in the sense because the denominator part we have the maximum order is 1. So it is the standard closed loop control system, the unity feedback system, and your plant that is 1 divided by t of s, that is nothing but your plant. And once if we simplify this block theorem, it becomes 1 divided by 1 plus t of s, where r of s is nothing but your input and your output is c of s. Your closed loop transfer function of a first order system, that is c of s by r of s, that is equal to 1 divided by 1 plus t of s. If the step input is unit step input, then R of t that is equal to 1 and R of s that is equal to 1 by f s. The response in S domain C of s that is equal to R of s that is equal to 1 divided by 1 plus T of s. Again, we have to go for here partial right now, that is becomes again R of s, substitute here our term R of s because here it is a unit step input, therefore R of s that is equal to 1 divided by s, and again here response that is nothing but here as 1 divided by 1 plus T of s. Again, you have to take out your term capital T as a common term, therefore at last we can able to get it as 1 by capital T divided by s into 1 plus s 1 plus 1 by t. So by partial fraction, C of s that is equal to 1 divided by t, again now s into, within bracket we have s plus 1 by capital T, that is equal to, we have to take a partial fraction, that is because we have a two terms, therefore a divided by s plus b divided by s plus 1 by t. A is obtained by multiplying C of s and letting s is equal to 0. Therefore, whatever the term it may be, you can at last your A is equal to 1. Then for obtaining your second term b, we have to put your s that is equal to minus 1 by t, and at the same time b can get it as a minus 1. And at last C of s that is equal to 1 divided by s minus 1 divided by 1 plus s t, because your coefficient of A that is equal to 1, whereas for a b it is minus. Therefore, 1 divided by s minus 1 divided by s plus 1 by t. For a closed loop transfer function, that is for a closed loop first order system, unit step response, if it is a unit step in response synthesis, 1 divided by minus e power minus small t divided by capital T. For a step response A as it is, again 1 minus exponential e power minus small t divided by capital T. So now we have to evaluate here C of t, where t is equal to 0, C of t that is equal to 1 minus exponential of 0, again exponential of 0 is over 1, therefore it is 0. When we look on to your graph, this is my unit step input at t that is equal to 0, we have an amplitude alone, and for my response of your first order system, I can be plotted for t, 2t, 3t, 4t, like that I have to plot my graph, and once if I plot these points in my graph, I can get the response of my unit step input for first order system is like this. So here t stands for your time constant of a system, and if in a time of 5t, the system is assumed to have attained a constant value. So at last the response of my system is first order system is 1 minus e power minus t by t. So that's all about your first order systems. So thanks for watching this.